My name is Sergey. I'm from Moscow, and I'm working for a company called Acorn. And today I want to share with you some thoughts and recipes that I found useful during my development experience in several programming languages. So basically it was JavaScript, TypeScript, and ClojureScript. But keep in mind that there is no silver bullet, so probably my recipe wouldn't work for every job you might have. But if you are trying to be agile, flexible to changes, and productive, I'm sure that those recipes will work for you. So first recipe, use tools that make your code simple. Very basic example. Say we have a book, and we want to get title from this book. It's just one line of code, but so many things could go wrong. The server could not respond, or we can run this code before we get server response, or it could be 100 of other reasons. And at some point of time, I thought that I can fix it with types. So I started using TypeScript, and instead one line of code, I've got 7. And just think about it. This is extra code, has nothing about your product or business logic. It's just some kind of workaround of single line of code. So what if this code would just work without any extra manipulations? And I found the answer. This is a ClojureScript code, and it's basically do the same as previous. And it will work no matter how hard you try to break it. If you're familiar with functional programming concepts, you might notice that this behavior pretty similar to maybe monad from other functional languages. And the good thing is that in Clojure and ClojureScript, you don't have to think much about it. You just use plain data structures and keep your code simple. But under the hood, it will work like monads. So next recipe, use immutable values. Immutability has many benefits, and it's really hard to overestimate. But for me, the most important thing in immutability is that you get the proper meaning of equality for free. So in this example, for human, it's obvious that those two objects are equal, right? But JavaScript, it's not. In ClojureScript, all data structures are immutable by default. So it's really easy to make assumptions about them. You could compare nested objects, arrays, sets, or whatever. You can simplify dozens of algorithms which operate on data. And you never have to implement things like should component update method inside React components. Due to immutability, you get the minimum re-rendering cycles in your React application. So I think it's a really great feature. So next recipe is focus on data. When we are talking about functional programming, we talk about pure functions, higher order functions, function composition, and things like that. But I think it's a little bit wrong view to the functional programming. I think functional programming is first of all about data, not functions. Of course, we will use a lot of them, but only to assist to the data flow. For example, in Haskell, pure functional language, you can do nothing without monads, even print something to the terminal. And those monads, it's just data structures that will be mapped to the side effects at the borders of your application. And this is true essence of the functional programming. You have a pure functional core and a very small imperative shell that know how to deal with the rest of the world. In ClojureScript, we don't have built-in monads, like in Haskell, but we have supercharged immutable data structures. And we use them to express things like HTTP requests, to deal with the browser APIs, and make third-party services communication. So data is our cornerstone, and you should keep focus on that. And the last recipe is grow your mindset. So ClojureScript is really awesome, and it helps a lot in a day-to-day programming. But I think the true value of ClojureScript is a way of thinking about programming in general, about programming problems. And today I have covered only a little piece of what ClojureScript can offer to you. Just give it a try. Start learning or write little pet project. Bring the main ideas from ClojureScript to your code, no matter which language you are using. I assure you it will reduce the headache and level up you as a developer. So, thank you.
Thank you, Sergey. Do we have any questions? We have time for maybe one. Now is your chance. Shoot.
No one? Maybe it was really fast.
It was super clear then. Thank you very much.
Thank you.
So, hi everyone, my name's David. I have a Twitter, coding_lawyer, and today I will tell you how to write better React. So, React is one of the most popular ways to build user interfaces in JavaScript. So, React is pretty cool, right? But could we make it even cooler, better? In order to write better React, we need to understand its problems. So, what's the main problem of React? Well, React isn't a native JavaScript library. I mean, if you take a closer look at it, you will see that some of its principles are foreign to JavaScript. Let's visualize this. Immutability. In React, we want to keep our stuff immutable. We don't want to mutate our state and our props, because if we did, we would get some weird consequences. In JavaScript, we don't have immutability out of the box. So if you want to keep your stuff immutable, you need to use external libraries, such as immutable.js, or do it by a convention. Functional programming. React is based on the functional programming. I mean, React applications are composition of functions. JavaScript, on the other hand, although it has some functional programming features, such as first-class function, it's not functional programming language. Because if you really want to write some nice declarative JavaScript code, you need to use external libraries, such as Lambda or low-fp. Type system. In React, we have a prop types. And prop types is a way how to simulate static types in JavaScript, because JavaScript isn't a statically typed language. If you really want to use some advanced types in JavaScript, again, you need to use external libraries, such as Flow or TypeScript. So if you take a look at our chart, you can see that the JavaScript isn't compatible with React's core principles. So the question is there some other language that might be more compatible with React than JavaScript? Fortunately, there's ReasonML. Immutability. In Reason, we have immutability out of the box. Functional programming. Reason is based on OCaml, functional programming language. Type system. Reason has strong type system. So if you take a look at our chart again, you can see that Reason is more compatible with React than JavaScript. So what's Reason? It's not a new programming language. It's an alternative JavaScript-like syntax for OCaml, the functional programming language that has been around for more than 20 years. And thanks to Reason, you can write OCaml using JavaScript-like syntax that compiles to JavaScript. And thanks to this, you can take advantage of all the cool OCaml features, such as its strong built-in type system or pattern matching and other features. But this talk is about React. And we can write React in Reason thanks to Reason React library. Maybe you are now thinking, why should I use React in Reason? Well, we've already mentioned that Reason is compatible with React. And why? Why is it compatible? Because React was developed for Reason. More specifically, it was developed for OCaml, because first React's prototype was built in standard ML, cousin of OCaml, then it was moved to OCaml and transcribed to JavaScript. And when React came into JavaScript, we need to adjust JavaScript to React's needs. So we created a lot of tools and libraries to make development smoother. And this means another layer of complexity for our application. So your typical React application will have at least these dependencies. Now, what do we swap React for Reason React? Do we still need all these dependencies? I mean, immutability. In Reason, we have built-in immutability. Static typing. In Reason, we have a strong type system built in. Router. We have a router built inside Reason React library. ESLint, linting. We have a compiler that provides us with readable warning and error messages. Prettier, code formatting. In Reason, we have Reason Formatter, and it's a built-in formatter that will format your code in the only possible way. Helper functions, such as Lambda or Lodash, we have enough helper functions built inside Reason. So if you write React in Reason, you won't need these and many other dependencies. And why? Because Reason is based on OCaml, the functional programming language, the matured language with all of its core principles and rules how to structure your code stable and in place. And I'd like to end this talk by citing the creator of Reason and creator of React, Jordan Walk. Reason is the best way to take React to the next level. Thank you.
Thank you, David. We have some nice questions for you here. Can you think of a reason not to use Reason?
Can you think about a reason not to use Reason? Yeah, that's a really tricky one. Yeah, so I guess still Reason is still under development. So sometimes you just don't want to use Reason. You just don't want to start throw away your app and rebuild it in Reason. The best way how to try it is to do it incrementally. So I guess you really don't want to be really hyped about that and start everything do in Reason. You need to think about it if it's the best thing you really want to build. So there's no answer like yes or no. It's always like it's up to you, right?
Does Reason integrate with JavaScript libraries reasonably?
Yeah, it integrates. There's a special. You need to write bindings, but there are many bindings already written, so you can use them as npm package. But if you need to use some library, some JavaScript library without these bindings, you need to write them yourself, and that's like thing you need to learn. So that's a little bit complicated part of the Reason. But the community is growing, and there are more and more bindings for JavaScript libraries. So you have, for example, bindings for React, bindings for Express. And the number of bindings is growing, so you can. This is the way how you integrate the libraries.
Thank you.
Thank you.
Okay, so hello everyone. My name is Svehla. I'm from Brno. It's like the second biggest city there in Czech Republic. I'm CTO in startup called FaceUp. In our company, there is like one programmer, it's me, and 2 freelance half-time developer. So we are really trying to avoid spending our time with unnecessary codes. Okay, so everyone loves JavaScript. JavaScript is super awesome and cool. And this function is really readable and awesome. But if we will call this function with bad argument, it will throw us runtime error, as we expected. And runtime errors, you know, we don't want it. OK, so how we can fix it? We should write some tests. But my CTO told me that it's boring and no one likes writing tests. So thank you. So we should try to write some static types. OK, second example is kind of similar as the first one. I have some human type. Yeah, I think it's really readable. And if I will put bad arguments to this function, it will not fall in runtime, but the app will not be compiled. So everything is awesome. But there is one bad thing. You have to define this interface. And I don't know what about you, but I have no time for doing it. OK, and real example, this is like standard application with Redux and REST API server. Now try to imagine where you have to define interface. There is so many places, every action, reducer, you know, it's really a lot of code. OK, so Redux is not the way. So how many of you know GraphQL? That's kind of nice, yeah. So GraphQL is like REST API on steroids. It's super cool and awesome. You define some schema, and you ask to that schema. There's like name is string, you know, tagline is string. It's really nice model of your API. So now try to imagine that your single-page application will be synced with server, your state of single-page application. If each of components in your application will be synced with server, and each of that component will fetch data directly from server, you can know the data types which will backend return. Because there is this GraphQL schema. If you will ask GraphQL, hey, give me name, GraphQL know that the name is string. So you can define schema on backend and generate static types from GraphQL schema. Maybe looks kind of tricky and magic, but I have awesome example. So this is my code. It's like average React component. And I'm like, hey, this is my GraphQL query. I would like to fetch ID, first name, and for example, second name. OK, now I will run my CLI compiler, which compile this schema and check if it's valid. It generates me static types with flow. You can see that there is second name, it's string. And now we can just write, hey, second name, OK, and try if it works. Interesting. Yeah, sorry, my fault. OK, yeah, and you see it works. And if I will do misclick, like give me viewer.secondName x and save it, Flow give me an error message that you cannot get viewer second name x because it's not valid, because my prop types are here and there is only second name and not second name x. So I have like 100% static typed application with 0 lines of types. And that's awesome. So yeah, that's it.
Thank you, Jakub.
Okay,
Does it work with Apollo?
Oh, this is a good question. No, it doesn't work. But this is a really modern library. It's from Facebook. It's really awesome. But if you want to start programming like this, you have to prepare that you will spend most nights with debugger and Google Chrome console, because this library is kind of hard to understand. So maybe, I don't know if Apollo is better, but no, it doesn't work with Apollo yet. Maybe sometimes.
Thank you very much, then.
OK.
Well, good afternoon, everybody. My name is Steven Nieuwenhuis. I work exactly at bol.com, the largest online retailer in the Netherlands and Belgium. And today I'm going to tell you all about our framework-independent components library built with Stencil.js. Well, at bol.com, our goal is to provide the best shopping experience for our customers they ever had. We do this with about 60 development teams, each with their own way of working, and each team is free to choose whatever tech stack they like. So some teams go for Angular, others go for React, and others tend to stick with Vanilla.js. The freedom of choice really enhances productivity, creativity, and adds to the products. But the downside is that, every team has different solutions to similar problems, which results in differences in the look and feel of a supposed to be uniform shopping platform that bol.com actually is. So we have to get those teams on the same page again. And how do we do that? Well, we ask the teams what they need to do in order to achieve this, and this was their conclusion. They basically need a components library that's framework independent, contains one single source of truth. They really want to be able to contribute. They want to have flawless integration with the current tech stacks. And they want to stop reinventing a square wheel over and over again. So no more different solutions for similar problems. But they want to keep their freedom as well. And besides that, we really want to enable all developers of all levels to contribute to the components library. So we want to make that as easy as possible. And last but not least, we want to have it performant and scalable as well. So this is quite a long list. And yeah, it was quite a challenge to find a solution to all the needs of the developers. And we thought we found a solution with web components. And web components makes us really flexible. We don't have to worry about framework lock-in. Components are reusable, and that enables us to provide components with a generic look and feel throughout our shopping platform. But, as always, there's a downside, and this time it's the learning curve, especially for developers that aren't experienced yet. It's very hard to build web components from scratch. And we really want to enable all developers of all levels to contribute to this components library. So we had to go for the extra mile. And we found the extra mile in Stencil.js. Stencil.js is a web components compiler which generates 100% web standards-based components. It's really performant, and they have a very easy API. It's future-ready, and we don't have to worry about framework lock-in. And best of all, it's compatible with all the major frameworks around, and even without any frameworks. So teams are able to implement it in their tech stacks flawlessly. So how did we combine the power of Stencil.js with web components into our components library? Well, we did it with this. Here we see our components library. The base is Stencil.js, and it basically generates web components. And if a team wants to use one of the components, it easily goes to the components library and gets one via our internal repository manager, Artifactory. And if they want to contribute to our components library, well, they simply do so with our repository that's available for all teams around. So that's how we combined the power of Stencil.js with web components at bol.com. So to conclude my story, everything we do at bol.com is to provide the best shopping experience for every user out there. We do this by providing a community of developers with the tools they need to get them together, get them on the same page, and enable them to speak the same language. How? By building a framework-independent components library with Stencil.js. My name is Steve Nieuwenhuis, and I would like to thank you for your attention.
Thank you, Stefan.
Thank you.
I think there are some people who want to know if there are any downsides of Stencil.js.
Yes, there are some downsides because, well, web components, not all browsers are fully supporting them. So you can see that as a downside of Stencil.js because Stencil.js builds on web components.
Okay, and what about any overhead to using web components in an application as opposed to classic framework-specific components?
Is there any overhead to using web components in an application as opposed to classic framework space? Yeah, well, there's lots. There's a bit more of configuration, and then, as I said earlier, polyfills as well. So you can see that as some overhead you have.
Okay.
Yeah.
What about browser support?
Browser support. Yeah, as I said earlier, Stencil.js is supported by all browsers. Say it with polyfills.
I think we can take one more, as you're very efficient. Why Stencil over Polymer?
Over Polymer. That's a very good question. We didn't want to be a framework. We didn't want to have a framework login. And so, yeah, after some intensive research, we ended up with Stencil.js because it suited our requirements better than Polymer as well.
Thank you, Stefan. Thank you. We enjoyed
Thank you
all
very
lightning
much.
talks.